So the Wispr Flow again embarrassed themselves. It hasn't been working, and I have been trying to reach them. And right now, Lily is responding to the comments, and they cannot get this together. So I reset the app, and still it doesn't work. Just applied the rough linter across the whole workspace. Need to commit this after fixing it. So I've been talking with these guys about the factory AI, about the prompt injection that I think has been happening. Uh, Noah Berman replied this: "What do you mean by prompt injection?" I mean, her VP of operations, Francisca, has tweeted many times about how they are partnering with organizations to stop that. And he is asking, what do you mean by prompt injection? I don't know. Do they ever read emails or pass in information to their colleagues or not? And I have been talking with Whisper too, because their UX keeps changing. In the morning, when you see the streams, it was 10, and this afternoon, the streak kept changing, and transcriptions for more than 1 minute didn't work. This is what they said I had to do, and I replied that nothing came through. And then I think so, this is a bot, uh, told me to retry that link, and I said it didn't work. I reset the app, so you can see the 28-second transcription didn't even work. I saw this. Let me bring in someone who can dive deeper into this. And after that, they have been silent. Right now, the 23-second transcription doesn't work. The 24-second transcription doesn't work. And these weren't the changes I expected. I just wanted to subgroup the crowded plot with the RSA plot only, not all of these. This doesn't work. The there's too many retries, and I've reported this issue multiple times, and I won't be able to recommend your app to a startup or an enterprise if you do not fix your issues here. And this didn't work even too. As you can see here, it's still spinning, and it will tell me to retry. Yep, something's not right. Transcription failed to load. They embarrassed themselves again. Sending a feedback. I don't know if even this will be sent. There's no confirmation in this app. Couldn't send feedback, but we copied it to a clipboard to try again later. See, that's what I'm fighting right now. Totally dumb experience. This is the so 1.4.642 version. VLM doc fix Python only build 404 fallback fused MOE wait loading. V8 MOE support detection R Rockum compile startup tests Mamba touch compile failure bad new attention mask logic. Add server models. I think so. This was added. So it has gone. The request made it through. Let's see where the execution is at. I think that this will take 15 minutes or so. Look at Do you check out this branch? Could you install UV and do the package installation of everything since this is a new checkout?
And I'm not going to spend too much time on this. I'm going to zoom through this. So I just want to mention that we have a open science community that gathers in a different Discord server. So after this phase 2, I suspect that our expedition server might get a little more quiet. And we just want you to know that there is a whole nother server with things happening all the time. And so, yeah, there are over 4,000 community members. Crossover, like I just saw a reaction from Katrina, so I know some of us are from there, but I just want to make it known that it exists, and I hope you join us over there as well. We have 18 programs currently running across a variety of subfields and regions, and so please join us over on that server. We'd love to have you there as well. I think with that, I'm going to pass it back to Madeline to chat a little bit about phase 3.
Yeah, so today's all about wrapping up phase 2, but I know lots of people have questions about phase 3. I made a post about this yesterday on Discord, but just to highlight some of what we're talking about here. Admittedly, this is a new way for our team to work. And like so much of we do, it's iterative, it's an experiment, and we're excited to do this experiment with all of you. Here's what we do know. Phase 3 will involve a lighter touch from our team. The big goal of expedition is to support you becoming independent researchers, to support you making relationships and collaborations that we hope last, beyond the container of this experience. And so this is phase 3 is kind of that gentle handover period as we support you break out into the world independently. So as we support this transition, we're going to suss out what the best way to keep working together is, what support is still meaningful at this time, and it will really be up to teams to evaluate how they want to proceed, what their next steps are. This will depend on the relationships you've built, your collective bandwidth, your collective goals, and early signs of project feasibility. Not every match is a perfect match. Not every project is meant to be a giant multi-month research initiative. That's part of research. This is, that doesn't mean a project has failed. That means that's just how this version of experimentation has worked out. And if that's the case, we'll be happy to help you find other projects to work on, other things to explore in that separate Cohere Labs server. Maybe Britannia, you can drop the link to that one in the chat to get people connected there. That said, if you're excited to keep working together, as I hope and guess many of you are, we'd love to help you work towards sharing your work publicly. This is open science after all. So really the next step is to decide what the next step is. For a lot of folks, it will be this: keep working. 2 weeks is not very long, and we get it. We don't expect you to instantly jump into a draft to write something to share publicly. And so if the answer is to keep working, we encourage you and support you to keep doing that. Our team remains available for technical questions you have about working with the model. We can be tagged into on other things. But I think in this situation, it will be more about your team coming to us when you have questions or when you need feedback on something. We will be less eyes on all your channels. We won't be chasing after you or pinging you for updates. It's really up to you how you want to make the most of it. And then the next step is to evaluate what's the best way to share this work. What medium is the right avenue for the message of your research. And there's lots of things that go into making this decision. Many of your mentors, will be taking a step back at this point, but I'm sure they'd be happy to kind of help you assess what's logical to work towards given your project and your resources, and help send you on your way towards that goal. And I think we'll talk a little bit more about this at the very end. But let's carry on. Okay, it's time for the main event. Let's launch into it. I think our first presentation, nice. Team 1, Alper, you start us off. I'm going to start the timer and I'm going to try to get slide controls too. But Alper, take it away. Yes, love this celebration. Let's go.
How can I control the slides?
I'm just working on that. So give me 1 second and we'll get you in. But for now, let me put you on your first one. Go for it, Alper.
So can I? Oh, okay, I can. All right. So can I start?
Yes, please.
All right. So in our project, we tried to utilize TinyAI as a backbone language model for like visual-speech translation tasks. And there aren't many models or data sets that can actually cover low-resource languages specifically for this task. And we picked Hindi and Turkish as our source and target languages interchangeably. And we wanted to come up with some working pipelines so everyone can try to generate their own data and train their own models. And it's like speech models usually have a codec model and the language model. The codec model is used to tokenize the audio in a way the language model can understand it. And then you can also use the same codec model to like decode the language model outputs back to audio domain. So the codec is pretty important for your selected languages because it kind of determines the overall the audio quality that flows throughout your pipeline. So that's why we picked some codec models and tried to fine-tune them both on Turkish and Hindi. And we weren't able to finish the Turkish trainings and evaluations, but we collected all the results for Hindi models that we got. And like these are the training strategies that we followed throughout the way. And then we got some results, but with the amount of data that we had, the results were not that tangible. So we just continued using the baseline Mimi codec that we had from the Moshi. And after that, we tried utilizing the TinyAI as the actual backbone, and it did quite a good job. And I don't want to spend much time on explaining this because I have some overfitted results from our trainings. I'm not sure if everyone can hear these. Oh, damn, I guess you can't. Is there a way that I can share the audio too?
I'm not sure. I've got presentation audio on.
Oh, yeah.
अटलांटा थ्रैशर्स पर वाशिंगटन के 5-3 की जीत में उन्होंने 2 गोल और 2 असिस्ट किए थे.
This is the source, and this is the generated Turkish translation.
Washington'ın Atlanta Thrashers karşısında elde ettiği 5-3'lük galibiyette 2 gol attı ve 2 asistle katkıda bulundu.
The translation is correct, but the audio quality is a bit off. And our next step is actually working on this by creating more high quality data sets. And that was kind of all. And thank you all for listening.
Alper, this is awesome. Right on time. Congrats on setting the tone. Yes, keep the celebrations coming. If you have questions, throw them in the chat. But I did want to highlight some really nice feedback. Irem, you're here. I'm going to share what you wrote about this team. Irem has dubbed this team the Underdog Uprising. Yes, I love it. This project is technically very challenging and has a lot of moving parts, but you've been doing exemplary work, breaking it apart into smaller chunks and working on each part. And you already have training results, which is so impressive in just 2 weeks. So huge congrats to the whole TinyAI Translate team. This rocks. Let's keep it moving along.
Thank you.
Next up, we've got TinyAI Math. Katrina, are you presenting?
Yes, I'll be presenting. Thank
Great.
you.
I've given you slide control.
Perfect. Yeah. So math is something that's really special to myself and my group as well. So we're really excited to work on this project. Our research question here was we're trying to improve the structured mathematical reasoning and reliability of TinyAI using International Math Olympiad style problems. And we were using SFT and LoRa. So basically our goal was to look at these Olympiad problem solving techniques. And we were evaluating this on 2 stages, 1 on the structured reasoning schema and 2 on the final answer correctness. So since these proofs are very complex, we decided to then break it down into this reasoning schema that has 6 different parts. So the idea, hints, key lemma, sketch, check, and final. And so we basically structured our whole data set in a JSON format to include these 6 areas. And you can see here in our graphs that we have different categories that we covered. So we had number theory, algebra, combinatorics, and geometry. So quite a wide variety of answers that we had there. So looking at our results, we found that we successfully taught the model to produce the structured reasoning. So we had huge improvements using both LoRa and SFT. And we did see some small improvements in the mathematical correctness. So we knew this one would be quite a challenging one to tackle, especially because Math Olympiad is so challenging. And also the model has no other mathematical training. So our schema correctness went from about 60% in the bench to about 90 to 100%. And then our answer correctness went from 3% 3% to around 7%. So what was interesting was that we saw that SFT did outperform LoRa in some cases. So we thought that was maybe because we had a smaller data set and there might have been some overfitting there. So we are aware of that. And we do believe our results stemmed from a weaker mathematical foundation of the original model. So we're trying to work with that. So kind of as a result, like for our next steps, we are very passionate to continue working on this project. And our main goal is to build a stronger mathematical foundation of the model. We recognize that Math Olympiad is very challenging even for anyone to solve. So we're going to start by training it on maybe high school and early university level calculus, algebra, and statistics before going back to the Olympiad problems. So we'll expand our data set, improve the quality where we can. And then once we've trained the foundation, we're going to come back and reevaluate on the Olympiad problems to see how it works. And yeah, that's all.
Amazing. Huge congrats, Katrina, and to the entire Tiny Aya Math Edition team. Yes, celebrate. Nico was the mentor here, and I love this. Nico wrote, he's dubbed you the chalkboard champions for being the best math teachers to Tiny Aya. I believe it. And it's very exciting too to see your plans for future collaboration. I hope that this gets off the ground and that we're able to continue to be in touch and support as you jump into the next phases of this. Bravo! Okay, I'm going to keep us moving along. Next up, we've got Priya, who will be presenting Tiny Aya for low resource information retrieval. Priya, do you have slide controls? Are you ready to go?
Yes. Hi, Britvanya. How do I verify that I have slide control?
I think you should just be able to hover over and see an arrow, but if not, just say next slide and I'll do it for you.
Okay. I'm starting off. Okay, so the problem statement for us was how to build an embedding model for low resource languages, specifically using Coher Labs' Tiny Aya global model for information retrieval task. And since Tiny Aya global model is basically the generation model, this was a very new task for this family of model. So our strategy was to focus on the set of 10 Indic languages as our LRL target, and we chose the LoRa fine-tuning technique with cached multiple negative ranking loss on query and value projections. We relied on Bharat Nanobeer benchmark and cosine similarity based passage retrieval, and that really helped us to evaluate our models. And if you ask us the experiment stages, we started with English only fine-tuning model to provide a strong scaffolding base for this LRL specialization. Then further we went ahead with the two-stage approach with English only fine-tuning followed by a single language specialization, that is Marathi, and we saw the effective specialization there. In the third stage, we thought of joint training with the long language balanced data sets, this time English and a complete Indic languages set, and we were able to see the good generalization. We also introduced the full attention instead of just the query projections and value projections to see if it helps us in the performance case. And finally, the two-stage curriculum where the stage one was the strong scaffolding based fine-tuning model on English, followed by joint language based training on English and all Indian languages, actually yield the best LRL performance for us. So if you look at the bar chart on the right hand side, that gives a visualization. The very tiny first bar is Tiny Aya Global, and the last one, which is the red one, which is from 0.044 to 0.366. 366, that's all approximately 800% improvement what we were able to get with this experiment. Now, next slide, please, Madeline. Yes.
Priya, we're going to have to wrap it up actually, but I'll put your slides up as I share some really nice feedback that we got from your mentor, David. Yeah, nice. David has dubbed the Tiny Aya for low resource information retrieval team the search wizards. Nice. He says that you've creatively experimented. You got good results, and you did it all with a really positive, collaborative, and supportive spirit. So huge shout out for this. This is the kind of approach that will no doubt carry into all your future collaborations. Great to see that you've got some next steps planned here as well. And really, really excited to see how this team evolves into the next chapter. Sorry we didn't get to your full presentation, but we're going to keep things moving here to get to everyone today. Next up, we've got Team 7, Listaya. Edwin, I've got you on for presenting. Do you have the slide controls?
Okay, thank you, Madeline. So again, thank you. Yeah, like this is our project overview. Again, I think, I think like we were working on another presentation. So yeah, but yeah, so basically the objective of this project was to like train a model for speech recognition based on TinyAya. We wanted to extend TinyAya to make it more inclusive for people who cannot have access to like, like text inputs, so that you can use it like on the go. And to that, we were going to use this commonly used architecture, like based on a Wispr encoder, and then it's going to be connected through an MOP to the TinyAya decoder. And that way we can, make it support audio inputs. So about what we did, basically, we did some experiments on different commonly used data sets for automatic speech recognition. In particular, this one is on different AdSense, and we compare what we were working, we call it Listaya, against other commonly used LALMs, including Bootstrap Mini and Qwen2 7 billion. This is still a work in progress because, while we did the experiments for Bootstrap Mini and Qwen2 on Listaya, it's still something that we are currently working on. And yeah, basically the next steps are going to like, because we fortunately meet some bugs, so we are kind of like fixing that like in the next few weeks. And we plan to like extend our car analysis to like more multilingual tasks, things like sentiment analysis and open-ended QA beyond ASR. And we also plan to basically understand the performance of these other TinyAya variants like Earth, Fire, Water across like different languages and how does that affect. And yeah, like just like a big shout out to like our team. For all of their like hard effort. They did a lot of incredible stuff. These are some of like the biggest like landmarks. Basically, they built the whole sentiment pipeline and LLM as a judge pipeline, like based on existing like frameworks, OpenASR, and also a spoken language understanding to support like many languages that are currently undercovered. And we hope that like we can eventually make this into something even better. Thank you.
Nice, Edwin. Congrats. Thanks. And congrats to the whole Listaya team. Julian was the mentor here, and he has dubbed the Listaya team the collaboration champions. Shout out for your multiple sub-teams. Whoa, this is next level. Multiple sub-teams working together, which was very well organized with a clear division of responsibilities, and just overall incredible work as a team. So nice to see this slide sharing all that you achieved, and the previous one about what's next. Really looking forward to more work from Listaya. Thanks, Edwin. Next up, we've got the safety team. Ashay, you get started, and then I'll give you slide controls.
Hi there. Can you, okay. Sorry, I just want to make sure that I have slide control.
Not yet. I'm just working on it, but go for it.
Got you. Could you just go back to the previous slide if that works?
Mm-hmm.
Sorry, I cannot control the slide for some reason. Okay, yeah, now I can control. Yeah. Okay, I'm going to start. So, hi, everyone. So, most safety evaluations focus on what a model says. We wanted to go deeper and ask, how is safety represented inside the model itself? And not just in English, but across languages. So we studied TinyAya Global to test whether safety is internally shared across languages, whether it shifts, and whether it can be controlled once identified. Our core thesis is simple. Safety isn't just a behavior, it's a structure. To answer that, we built a full probing pipeline. We extracted activations across 36 layers and 10 languages, used diffmean to identify safety directions in activation space, ran steering experiments to test causal influence, trained a 16,000 feature space sparse encoder to recover interpretable safety features and then analyze cross-lingual transfer. So this was not just one isolated result. It was a full stack: representation analysis, causal steering, feature decomposition, and multilingual comparison. The key result is that safety has real internal structure. Harmful and harmless prompts begin to separate in representation space, especially the middle layers. Harmfulness is encoded quite similarly across several European languages, but varies more for Hindi and Bengali, where tokenization plays a role. At the same time, refusal is decoupled from harmfulness across all languages. That means that the model can internally recognize that something is harmful, but whether it actually refuses depends much more on language-specific refusal representations. We also found that layer 16 has the strongest intervention point. Steering along diff means successfully found steering vectors that control whether the model generates harmless or harmful text in response to harmful requests. The takeaway is simple. Safety is not random, it is flat, and it is not visible in outputs. The next step is precision. We want to move from global steering to feature-level steering, track how these safety features emerge during fine-tuning, test whether what survives when the preamble changes, and better classify weak or missed refusals. The final message we want to leave with is this: we do not just measure multilingual safety at the output level. We found evidence that harmfulness and refusal are represented differently, that safety structure transfers unevenly across languages, and that parts of that structure are steerable and controllable. We started with an open question. We're leaving with evidence that multilingual safety is structured, uneven, and steerable. Thank you.
Nice, Ashay. This rocks. Great presentation. Thank you so much. Your mentor and the mentor for the whole safety representation team was Evie. Evie has dubbed you the safety guards. Awesome. She writes that you're a really motivated team with great progress in this short time, very responsive with updates and incorporating feedback, and that you're interested in understanding how safety directions are encoded in different language and in the general model behavior, which varies across harmless and harmful prompts in multilingual settings. So shout out for your great work as the safety guards, and thanks for this great presentation. Nice. Next up, I'm going to move us along to Team 10. Michael, Gusti, you're sharing the Tiny Aya vision. Michael, I've made you slide control, but Gusti, let me know if you want it to.
Thank you. Yeah, so this will be our update for the vision team. So our architecture has frozen SIGLib2 encoder, pixel shuffle for 4x token compression, and sweet glue NLP connector, and frozen Tiny Aya global. Only 2% of the parameters are trainable. We have an end-to-end pipeline on model cloud GPUs, completed alignment on Lava pre-train, and built top K tokens in L2 norm evaluation tooling. On challenges, GPU constraint pushes us to models pay per second model, and we switched to instruction tune Tiny Aya Global for better merging compatibility. I'll let Guzi explain the result.
Gusti, are you on the call? We can't hear you if you are. Okay, Michael, I think you might need to carry us through this one.
No worries at all. The blind baseline scores 25.6% on CVQA after English-only alignment. That jumps to 45.5%, a nearly 20-point delta confirming real visual grounding, not just language prior. Even at 3.35 billion parameters, we're competitive with 7 billion plus models across 31 languages. The per language breakdown shows a Latin language script language leading, while low resource script like Sinhala and Oriya sit at the bottom. Exactly what milestone C's target, which is the next step. Hold up. So 3 milestones. A, English only alignment, SFT and cross model merge. B, add multilingual instruction data and measure zero shot transfer. And C, culturally diverse visual data targeting those low resource script gas. And beyond expedition, we're planning merge racial sweeps, LoRa ranks ablation, and script specific pixel shuffle analysis for our CPR or NeuroIPS paper. And that's it. Shout out to my team, and thanks David and Marzia for the guidance. So
Nice, Michael. Yeah, shout out to the whole team for sure. Go Tiny Aya Vision. David was the mentor here. David, I love this. David has dubbed this team the Vision Lords. We got to get that on your resumes. You've earned this title because you are pioneering the training of the Tiny Aya Vision model with exceptional ambition, precision, and organization. What a trifecta. Huge congrats, Michael and the whole Tiny Aya Vision team. Great to see your early wins here and looking forward to what's next. Next up, we've got Team 11, offline multilingual AI voice companion for kids. Batuan, is this you?
Yes, but I'm not sure whether the slides are synced or not. But is it possible to like do another refresh, or like I can
Okay,
just
let
use the
me
one
get
we have?
that going. Team 11. Cool, let's do it. How's this look?
Not a lot of change, but yeah, that's the right one. So we are here with the least aesthetic slides probably. Our idea was like pretty simple. By the way, we thought that like every child deserves access to intelligence, enough intelligence, starting from the early childhood, because it helps them to like craft their like the way they think and the way they explore the world and understand the world. So we decided to put Tiny Aya Global into a mobile phone and wrap it up with an STT and TTS layer to let like every children talk to intelligence, ask their simple questions about the world. And like it's like kind of working, but like I'm in a loud environment so that I can show the like voice interaction, but you can just send a message and it kind of like responds. We are hoping to like share the test flight version with everyone in the cohort. So hopefully we will share the link in a few days. We can go to the next slide, or maybe I can move it. All right, perfect. And meanwhile, we were like benchmarking Tiny Aya with the larger models to see the difference, like the trade-off of running this small model offline to serve to the children. And we see that there is not much difference with the larger models, because like most of the children questions are like pretty straightforward and simple, just to like explore the world. And we took those questions from a real application that children use to like talk to another like cloud provider's model through 11 apps. So these are real questions. We put them all into an interface so that you can explore. Let me share the link with you. And so we needed to like extend the coverage of the benchmark, both with more questions and also like questions in different languages. And we thought that maybe you can help us. So we put kind of like Aya Arena into action. So you can go to the link, you can just type any question in different languages, click button, and then you can see results coming from different models. You can pick the best one and like give your vote. So yeah. Help us improve the benchmark, please. Thank you.
This is awesome. The team grows. We are all now a part of Team 11. Thanks for the presentation. Thanks for the fun phone demo too. Lots of things to look forward to here. Shout out to Team 11. Your mentor was Virat. Virat has dubbed you the multilingual whisperers. Yes, nice. Incredible enthusiasm from this team working on TTS and STT with the Tiny Aya in between for an app that has a very clear application. So bravo to Batuan and to the whole team. Amazing. I'm going to move us along. Next up, we've got Team 12. Michael, over to you. Do you've got the slide controls there?
Yes, I do. Thank you, Madeline. And yes, our team worked on cross-lingual word sense disambiguation with Tiny Aya. And for those who don't know, word sense disambiguation is the task of assigning the correct meaning to a word in context. And it is incredibly useful for studying lexical semantics, even though it might seem apparently simple, but also to see if a model actually has a complete grasp of the semantics of a language. And we structured this task across two different subtasks. The first one, candidate matching, so the model receive a series of candidate meanings and choose the best one. And the second task involved the generation of a definition for a certain word without predefined candidates. We gathered data as the first step by obtaining access to Excel WSD, which is a very large annotated data set based on BabelNet, which is a large data database covering 18 languages, and then we added 2 independent datasets for Hindi and Bengali. We ran some experiments on small samples of this data to choose the best prompts and evaluation metrics. We tested TinyAI Global, TinyAI Water, which was the main regional variance for our use case, also Fire, Quen 3.5 for B, and Gemma 3 for B. We fine-tuned with LoRa TinyAI Global for both tasks, and we ran some analysis. And as you can see in the table at the left, we covered 20 languages in total. For the first task, our fine-tuned model actually scored the best, reaching almost 0.6 overall accuracy across all languages, but performance varied a lot between different languages. And we also had managed to beat the base models for the second task based on sentence birth similarity distribution. And we noticed that clear prompts were fundamental. Models tended to be tripped up by something like negation. And we overall discovered that fine-tuning TinyAI can unlock new performance. And I'll just wrap it up very quickly. You can see that performance varies a lot between different languages. We had some first outputs as the 2 fine-tuned models and the comprehensive dataset and benchmark. And we saw some evidence of cross-lingual transfer on Chinese. So we hope to continue working on this great project.
Amazing. I'm so glad you hope to continue to work on it because it does seem like a great project. Congrats, Michael, and to the whole team. Amar was the mentor here. Amar has labeled your team the Data Whisperers. You've had amazing organization since day one, and incredibly impressive width of experiments and depth, but most importantly, nice creativity in working around limitations in data scarcity for an OG NLP task like word sense disambiguation. So huge congrats to the whole team here. Great to learn more about this work and the progress you've made. Next up, we're moving on. We've got Team 14, Language Aware Quantization. Vivek, over to you. I'm starting the clock.
Thank you, madam. So our research question was to understand, what are the effects of quantization on language-specific tasks, and if we can, study or maybe reach this kind of degradation by changing or experimenting with a lot of data curation strategies. So we started with 3 languages, that is English, Hindi, and Ukrainian, and we took the multilingual C4 dataset, which is available which is common crawl. And since this data is common crawled, it will have a lot of impurities, a lot of amalgamations, and the noise. So we used a token-based filtering for each of these languages and did a lot of duplication and cleaning, so that we get a very good quality of dataset. And we also, created a synthetic dataset for Hindi. Now, C4 dataset or the common crawl dataset would be very random, and we wanted to study the task-specific, performance degradation. So we created a synthetic data for a lot of these topics like reasoning, legal, or even STEM fields. And so it was very diverse as compared to the other combinations that we tried using C4. Yeah, and for quantization, we followed a standard procedure of using off-the-shelf libraries like NLP compressor to quantize these models in using techniques like iterative and GPT. And this was the design performance that we got. So we evaluated TinyAI global on global ML for these 3 languages. And since global ML is a CPU type of the data benchmark, we store exact match as the evaluation. So there's the design performance that we got. And the reasons for the preliminary quantizations were there was a performance drop in English and Ukrainian, but we didn't really get any performance degradation for Hindi and even for synthetic Hindi calculation. So our next steps will be to actually run this wells again, and also to make a lot of different combinations of this data using synthetic and a mix of common crawl data. That's it.
Nice, Vivek, thank you. Great to hear from you and the early success of the language aware quantization team. Your mentor here was Sora. We also had Alejandro with some eyes here. So your honorary title is the Future-Proof Pioneers. Nice. This is for exploring efficient solutions to problems that affect many communities around the world and trying to make AI usage more equitable. Really nice to see this work so aligned with many of the missions of Cohere Labs as well. Congrats to your whole team. Next up, we've got Tiny Facade Bronson presenting on behalf of your team. Over to you.
Hi, so I'm just going to go straight into it. So the idea behind Tiny Facade is that we want to have sort of like a languages hub. Sort of what we've seen is that everyone wants to build on top of Tiny Aya because of the multilingual capabilities, but we also want to take it a step further. We think that tool calling is also something that's very important for these different applications, especially when it comes to things like translation and basically what you've seen in terms of speech and all that. So what do we do in this particular case? Ask ourselves a few questions. Number one is that can Tiny Aya even actually do tool calling in the first place? So we actually go ahead and we run some benchmarks using the massive agents dataset, and we actually find that it's actually able to, if you actually give it if you prompt it using the Hermes particular tool calling format, and we compare it against command R, which is actually trained on tool calling, and we see it's actually pretty consistent across different languages. So moving on, we actually find something which is really interesting, which is that 4-bit quantization actually beats the FP16 in almost all cases, except of course there's which is I think the biggest finding that we had. We actually started out with one language, and then we found that we actually had to expand to more languages. But that is what we can find for all the different languages. And the ones that actually suffer the most are Southeast Asian languages and African languages in terms of performance. But just moving on, we also find out that greedy decoding is actually much better if you actually want to do tool calling, and that we run this across all the different families, and we find that also the specialist models degrade much better than actually the global model in this particular case. And African models actually do degrade the most in terms of the temperature if you do move all the way up to 1. And also we show the different results for different languages, and we see that Burmese is actually one of the languages that's affected the most. So we actually have the application that's already out. It's already you're able to do tool calling. Basically, we don't fine tune anything. We just basically put out the application and a test client that you can actually build, which is actually like a thin client that is wrapped around the facade. And so maybe just to talk about some of the things that we actually able to put out. We actually put out the GGUF for all the different tool calling models based on a llama. We actually put out a cloud scale for you to be able to build your own thin clients on top of Tiny Facade. We put out the Android application and also the test client. We put out Linga, which is the translation application. And we also did fine tune on Luganda and also did extend the massive agents benchmark to Luganda. So we have a few things that we want to do next, which is actually being able to make it easier for you to distribute your applications, and also publication and LoRa adapter integration. A lot to say, but yeah.
Wow, really powerful presentation, and look at this slide. I'm very impressive. Glad to see the celebration coming. Congrats, Bronson and Tiny Facade team. Julia was your mentor here. Julia, this rocks. Julia gave you the Wait, That Worked award to celebrate that beyond great collaboration, communication, and coordination, your team found a surprising hack where quantized models are better for tool calling. So bravo, this is what science is all about sometimes. Thanks, Bronson, and congrats to your whole team. Next up, Team 17. Inference time optimization. Pia, nice. Ricky, you're presenting here. Go for it, and I'll get you the slide controls.
Thank you. Pretty cool presentation so far. Hello, everyone. We started with a question. How do you prompt Tiny Aya? And how substantial is it to the performance of the model? And the initial findings that I believe we've reported here gives us kind of like the first contact of what might be possible, especially in a language like ours, Burmese, which often tends to be the one that gets the least coverage. We focused on 2 types of tasks in our research. First, MMOU Lite, which we translated last year, and then machine translation, which is the one that I'm a little more excited to talk about on the Flores dataset using Google's Metrics X24, which is the standard now. So we began with MMOU Lite, a few of our obvious expectations were met. Although TinyAI covers Burmese understanding more, and I do think this is the case, in MMU Lite, it does not show a clear superiority over the global model. And we believe this is because it's easier to understand the questions given the, or it's not that it's easier, but it's fine. Doesn't really matter. But in chain of translation specific, it global outperformed TinyAI Water. And we're going to see somewhat of the same pattern here. And based on these findings, we kind of collectively all agreed that, okay, standard prompting techniques are fine for factual questions. The interesting thing that's going to be more relevant and what we've been trying for the past week, but we've kind of not had the best results, was agentic tool calling. The previous team kind of showed that, and it makes me a little more excited. But yeah, that's the MMU Lite scenario. And if I can show the translation, in the translation, this is kind of where TinyAI Water supremacy shows a lot. And oh, I got it speed up. Okay. We see that it's really good for both directions, Burmese to English, even across global and Command A, which is a much, much bigger model. And we believe this is down to the fact that it's actually a stronger model in Burmese. So that's the case. We also tried including things like dictionaries and context clues, but that didn't seem to help because it's the case that the longer the prompt gets, the least instruction following capacity the model maintains. So it gets a little more confused, I believe. But yeah, ahead of us, there's a lot of agentic stuff we want to try. And I want to leave the presentation with that note. Yes.
Nice, Ricky. Thank you so much. Yeah, we'll leave this slide up as I shout out your team. So great to see our Burmese community alive and well. They've been with us since those early Aya days. Really nice to see the growth here and the continued dedication. Amar is your mentor, and he's dubbed you the Simplicity Sorcerers. Very fun vibes, good collaborations, and the result that the simplest optimization method works the best. That's really quite interesting, actually. So great findings in this short period already, and exciting to see that you've got future plans up here too. Thanks, Ricky. Next, we are going to mapping hallucinations. Sinem, over to you.
Thank you. Can everyone hear me?
Sounds good.
Okay, wonderful. Okay, so we wanted to look at different types of hallucination. We want to look at how hallucination behavior is different between the global and the fine-tuned variants, and also like across languages. We're also interested, and we did see a little bit of a hint of this across different like hallucination metrics that one might find. So the behaviors that we were looking at was hallucination rates, cross-lingual consistency, cross-model agreement, and prompt sensitivity score. And due to time, I'm only going to be talking about like a very small subset of our experimental results so far. And we were looking at two different data sets, the MQQA and the XNLI, and you can see like the distribution of languages that we saw across like that are in these like different data sets. And we have an factorial experimental design. We have 4 models, 2 data sets, 8 languages, and 5 reps each, right? And MQA QA is basically our limiting factor. So if we look at like the hallucination rate in the MQA, it looks like everything's fine, and you get to see a little bit of a change. Or, I mean, everything's the same, and then you get to see a little bit of a change when you move on to the other data set. And we can see that also within like model and language agreement. These are 2 different types of analysis. One is based off of log props and the surprisal, right? And the other one is based off of the multilingual embedding. And what you end up seeing is that basically you see that there's a difference, right, with the global, but not so much when you look at like this other metric. So our takeaway so far is that the hallucination rates are pretty high, and the different measures can give different estimates of model and behavior and preferred model. So our next steps will be to look a little bit closer at our data and analysis from some statistical tests, 2 different groupings, correlation between matrix. Also, we want to get a finer grained understanding of this hallucination and why these data sets are, why it's so data set dependent. Equally, we'd like to expand the language coverage, but I think we also want to kind of start looking inside of the black box and try to see if we can find some mechanistic understanding of why these hallucinations are happening when they're happening.
Nice. Sanem, thank you, and congrats to the whole team. Really nice science in play here. Beza, your mentors dubbed you the documentation dynamos. This team has focused not only on results, but on making sure your process is transparent, reproducible, and easy for others to build upon by creating thorough proposal and experiment documentation. This is really thorough work. Bravo. And yeah, excited to see where you all take this next. Thanks, Sanem. Awesome. We're going to move on. Next up, we've got Tiny Aya Sinhala. Yes, another strong group that's been with us since the beginning. Let's go to the Sinhala team.
Yeah. Hello, everyone. Hope I'm audible. All right. So really amazing presentations, by the way. So we are Tiny Aya Sinhala, and we are from Sri Lanka. And our goal is basically instruction fine-tuning for cultural fluency in low-resource LLMs and focusing on low-resource languages like Sinhala. Right. So this is the current state of Sinhala NLP. So this is our country's flag, by the way. So it has a population of 23 million. And as you know, it's a very low-resource language. And even just before in the Vision project team, I just saw that Sinhala is ranked lowest. So this is what we're trying to improve, to make sure that Sinhala is not underrepresented in LLMs and how people can basically integrate Sinhala language data into LLMs. And when we talk about cultural fluency, I want to fixate on this a little bit because we're trying to make sure that in the Sri Lankan context, the model understands its history, religions, customs, traditions, the values, and everything that's there in the Sri Lankan context in its population. So this is the training data set preparation, what we did. And this is a combination of all the data sets from Alpaca, Bactrian, and also Sinhala that we did before. And it's also a little bit of high quality data set of the cultural knowledge that we injected into our data set, training data set. So we used RunPod and NVIDIA A40 to basically fine tune our models. And we did TinyAI Fire first, then Global for 3 epochs, and then Quen as well for 3 epochs. So what we noticed was these are some of the hyperparameters and the technical aspects of it. So we did a human evaluation part, and what we noticed was the average score was highest in Quen, and the link to our human evaluation analysis is here in the QR as well. And if you look at the benchmarking that we did with Sinhala MMLU, you can see that there is a very high contrast when comparing TinyAI Global with Quen 3. So yes, Quen outperforms both TinyAI variants, but we noticed that TinyAI Global is much lower than TinyAI Fire due to its, even though we did much more epochs with Global. So we hope to do more on this, and we hope to do continual pre-training on TinyAI Global and then do SFT. And with that work, we hope to publish a research paper and hopefully make sure Sinhala is represented everywhere. And if you want to check out our findings and everything, you can check out of this as well. And thanks to everyone in the Cohere team and everyone who helped us out. Thanks.
Thank you. Sam was the mentor here, and he's dubbed you the multilingual maestros for adding Sinhala support to TinyAI. Yes, we always want Sinhala represented here. Thank you so much, Sayuru, and congrats to your whole team. Going to move us on. Next up, we've got TinyAI Browser. Who's presenting here?
Shaw will present. Shaw, are you here?
Mohammed, are you on this team? Are you able to present? Or
Yeah, sorry, it wasn't unmuted.
Nice. We've got
Hello.
you. Hi,
Yeah,
go for it.
Yeah, I'm Shagaya, and we are from Tiny Browser Aya. So we are investigating if a small multilingual LLMs can act as a browser agent using only just the prompt engineering. For the future, we will do the research on multilingual setting, but now it's just done in English. So we designed a pipeline with 3 sections, like re-ranker, and we use for the first one is re-ranker, like we are re-ranking with Cohere rank model to get top 100 elements, and tournament that LLM select the best element, and for action it's predict click or top or type or value. So we used a Mind2Web dataset, which is airlines subdomain, and we have like 100 sys tasks, and we constructed this dataset in two settings to have like medium and hard level task to see how the model is able to see to do hard tasks also to compare to medium tasks. Maybe next slide. Sorry. Yeah, so the pipeline is in 3 sections. So re-ranking for query enhancement, and also it's going for action decision. So for action decision, like we set some rules and we did some reasoning to force the model to follow some rules. And then we have like tournament decision strategies, and maybe next we have less time. Yeah, and we presented our results in 3 settings, like overall performance, like for comparing to very simple prompts and or integrated prompts for by difficulty levels and quick operation and type operations. And for all of the settings, we got very good scores for browsing. And the next step, we will focus on a multilingual setting, more reasoning and planning, maybe fine-tuning or rankers, and that's it.
Amazing. Thanks for the presentation. Your mentor, Nico, has dubbed you the hyperlink heroes. Yes, for smartly architecting a pipeline that helps TinyAI navigate the web, even though that's really tricky with a tiny model. So bravo here. Thanks for the presentation. Next up, we've got Team 22, and Kita, handing over to you.
Yes, thank you. I think I have slide controls, so I'll try. Okay. So our project was on context robustness and cultural norm reasoning. And through this, we hope to investigate whether multilingual LLMs really adapt to the cultural context that is given in the prompt, or if they rely on more superficial cues like the language or the country labels. And we did this using one data set, which was NORMAD, which was also used in the TinyAI paper for evaluations. What the data set looks like is you have a question, and then the answer may actually vary based on the country the question is asked in. So for example, it may have a different answer in India, but if you ask it in general, it may have a different answer. To do this, we tested it across various modes. We varied a lot of things in the prompting that we used, and that resulted in a lot of runs, about 400 experimental setups, and then an aggregate of 2,400 runs approximately. And I'll just explain the variations we did in the prompting. We varied the language of the prompt, which was English versus the local language in the country versus a mismatched language, something like a language of a different country maybe. We varied the amount of context that we gave in the prompt, which was just no context, just the prompt. Then we gave the country information, then we gave the country and the values associated, or the country as well as the rules of thumb. These are fields in the NORMAD dataset that you can pick. We also tried to give some conflicting cues to see how that worked. So the baseline was just no conflicts, but we tried to also giving some wrong rules. So the correct country with the wrong rules, and then the wrong country with the correct rules. And just for fun, we also gave a made-up country to see what happens. And also, since we had 2 classes of models, global and regional, we tried to see how that affected the outputs. I'll just quickly go over some of the findings.
Yeah, we've got to wrap up. So why don't you share one main finding, and then we'll move on. Thanks, Ankita.
Sure. So one thing is that models do treat language as a proxy for culture, which we found out using flip rates. The other thing was that having the wrong country information actually increased accuracies to some extent, which we found a bit weird. But then using the local models helped helped for a specific country than using a global model, which was interesting to test out because, yeah, that was good.
Amazing. So sorry to have to rush us along, but hoping to get to all presentations. Congrats to your whole team. Your mentor, Nikita, has dubbed you the Global Citizen Award. This is for considering cultural evaluations as a central theme rather than an afterthought and finding avenues beyond the original setup. Every experiment design and decision involved diverse languages and geographical regions, which truly allowed to understand the next challenges for building accessible models. Really strong work here. Thank you once again, Ankita. I'm going to bump us forward. We have I Am Multilingual Reg Pipeline up next. Who's presenting here? Do we have Crew or Nightbee on the call? Okay, I think we'll bump forward, and if they join later, we can welcome them in. Let's move over to Nav. Nice, you're ready to go. We'll put you up. Mix, fine tune, and break. Go for it.
Yeah, I'm ready to go, and I hope to eat into some of the time that the previous guys gave me, I guess.
I don't know about that.
All right. Hey, I'm Tanav, and we are Team 24. Special shout out to Theo and Luna for being our morale boosters. Our goal was code mix, fine tune, break stuff. Code mixing basically is how billion multilingual people actually talk by mixing languages mid-sentence naturally. TinyAI is built exactly for these communities and meant to be fine-tuned locally by them. But that openness comes with a question nobody's answered for multilingual models. What happens when someone fine-tunes on harmful English and code mix data? The IA 101 model card explicitly defers red teaming to the community, and we are that community. So we ran 2 fine-tuning experiments, one on beaver tails and English harmful dataset, feeding the model increasing sizes starting from 10 up to 1,500 examples, and our own code mix dataset across high and low resource languages to see if the picture changes when we fine-tune, when the fine-tuning data itself is multilingual. On English, fewer than 50 prompts were able to break safety. Malicious compliance goes up from 3% to 33%, peaking at 42%. Prior research showed similar results for GPT 3.5 and Llama in 2023 and 2024. More than 2 years later, nothing's changed. So here's where things get interesting. We evaluated everything on the CSRT dataset, that's the code mixing benchmark, using LLM as a judge plus some manual review with 5 category taxonomy: safe, harmful, refusal, invalid, and the one that surprises the most, confused. Roughly 40% of code mix prompts fell here. The model treated each request as a translation exercise, invented benign interpretations, latched onto one word, and went off topic. This is completely stable across all fine-tuning sizes. It looks like robustness. It's not. It's confusion, and it will disappear when models improve. To run bilingual experiments, we built our own data set from scratch. CSRT is about 3 years old, and people are already benchmarking it. So we built like a dynamic pipeline where live news data comes in across 7 harm categories. It's filtered, it's code mixed, it's LLM's code, and partially like native speaker validated by us. It's not a static data set, it's a pipeline you can rerun as the world changes. We have some next step plans, which I won't be talking about in the interest of time.
Tanav, thank you so much. Sorry to cut you short. Not for lack of excitement around this project. Love to see all the hype. Your mentor, Charlie, dubbed you the collaboration champion. This is for, oh, this is awesome. For generously sharing compute credits with teammates, for coordinating and coming up with solid agreed upon experiment plans very efficiently across a 6-person team, for always sharing an agenda in the team and always collecting everyone's thoughts and questions well. And just asking your mentor when support was needed. Right on. Great to hear about all that amazing collaboration. Congrats to your whole team. Next up, Sude. Nice. Go for it, and I'll give you the slide controls, Sude. Do we have Sude or someone from Tiny Switchboard on the call? Okay, we'll skip ahead over this team and hope to
Okay, we are you. we will make our presentation, but I think the presentation is not up to date. We updated some of our pages.
Okay, let's do a quick refresh for you and get you going. How's this?
Okay, thank you. And Kyra will make our presentation.
Okay.
Hello, Ezra, are you presenting? Who will be sharing?
Can we go? Oh, okay. Okay, we are here. Sorry, we had a little technical difficulties. I think about the connection. Okay, I can go.
Go for it.
Okay. Okay. So in here, our ambition was to use all the regional models to create the best response to a prompt in different cultural and language aspects. So in here, we use the prompting pipeline. Okay. So we have a four-gated pipeline for our routing. In the first gate, we're checking out the language of the given prompt, and we are matching that language of the given prompt with the accurate tiny regional models. And using these candidates, we are making them all produce smaller responses and checking each response's PPLs and its accuracy about its confidence. We are picking a best model, and with the best model that we picked, we're making that make the full response. And in the gate 3, we're checking that full response, so we that have an accurate one. If the gate 3 fails, so the auto reward model declines that, so we are going for a fallback and using the global model. And also we try to use the memory usage as low as possible, so we are all using these models sequentially. And also we have tried to fine-tune everything to make these passovers as fast as possible. And in the end also we have if we have the last model is going to be for the fuller response, it's not going to be unloaded, and we'll go from there. And in here also we can see the fallback mechanism. If there's a problem with the latest response, we're going for the fallback. And we have created a ground truth dataset from the scratch. So in this dataset, we try to be diverse as possible in languages and in cultural concepts. So in that, we have created 120 prompts, and it was 86% correctly routed, and our fallback rate was below 3%, which is good. And also our reverse score was generally high too. And as you can see in the model usage diversion table, we can see that our dataset was diverse as possible. And in the future, we try to create a better dataset using more better ground truths from you. Is this possible? And also we try to make the accuracy go better. Thank you.
Wow, Ezra, Ijmet, bravo to you and the whole Switchboard team. Congrats on overcoming technical difficulties as well. It sounds like your honorary title is the Midnight Oil Burners. Nice, for bravely wrestling with memory limits and tuning hardware constraints into research innovation. Bravo. So glad we were able to get you on the call and presenting. Thank you very much for sharing your work today. Nice. Next up, we've got Team 27. Who's presenting here?
Hi, yeah, I'm presenting along with Aisha. Okay, so I'm just going to breeze through this. Our research question is, when misalignment is introduced in one language, does it propagate across languages through shared multilingual circuits, or does it remain localized in language-specific pathways? For our experiment, we fine-tuned TinyIA Global on a data set of insecure code in English, following the same setup from the original emergent misalignment paper. Before extending this cross-lingually, we validated two key things. First, that emergent misalignment actually appears in English, and secondly, that what we're seeing is true emergent misalignment, not just a jailbreak effect. To test this, we compared the EM model with the jailbroken version of the TinyIA Global model. And what we found is important. The EM model is added to jailbreak. It scores lower on the strong reject benchmark, yet it shows a higher rate of misalignment. So even though it's more robust to jailbreaks, it still exhibits emergent misalignment. Once we established that, we built a full mechanistic interpretability pipeline to investigate whether this misalignment propagates cross-lingually through shared multilingual circuits. I'm going to pass it on to Aisha for the results and future.
So what we found was that there is certainly a clear emergent misalignment direction, because there was a clear separation between misaligned and aligned responses when we evaluated with English. However, the transfer to other languages is kind of like, it's not very concrete, because there is some transfer to there was some transfer to 5 of the 7 languages that we evaluated. However, Hindi and Hausa showed almost negligible cosine similarity with this EM direction, and we hypothesized that this is because Hausa is quite low resource, and for Hindi there was not a lot of misalignment, which led to like this hindrance in finding actual cosine similarity. So for the next steps, we plan to strengthen our findings by increasing the number of samples, responses that we sample from the models, and also trying activation, patching, and steering with the English EM direction. And one more thing that we found when we replicated experiments on TinyAya Fire was that even though the cosine similarity with the EM direction increased, however, the misalignment rate decreased, which is probably due to the increased instruction fine-tuning on these specific models. So this creates a kind of a paradox, and we look forward to investigating this in other variants as well.
Amazing. Congrats on the progress here. Thanks both. Your mentor, Daniel, has dubbed the documentation dynamos. Nice. Your team was excellent in documenting every step in the project. Tons of PRs, notebooks explaining every decision and next step. Solid updates from everyone. So huge congrats on this incredible collaboration. Next up, wow, we are flying through and we still have a ways to go. Thanks for your patience, everyone. We've got Safety Aya. Okay, nice. Who's presenting here?
Hi.
Hey, go for it.
Yeah. Hi, guys. Our main project implementation was around multilingual cultural level safety guardrail system. The main motive of this was to rather than running two different models at the same time, why can't we use the original models with the LoRa pre-trained adapter for this task? So this is the basic workflow. So we curated total of 4 different data sets. We did classification on FineWeb 2. We did like translations on Nemotron Safety Guard, AGS AI content, and Beaver Tails. The total sample size of it, the total sample sizes are around 435K, around total of 1.04 billion tokens across 3 different languages: English, Telugu, Hindi, and Portuguese. Okay, English we actually did not did anything on English because it is already available. The distribution, this is the distribution of different data sets. So we have used for safety classification, we have used GPT-OSS for Telugu and Hindi. We have used Command A for Portuguese for safety classification. We have used to run GPT-OSS 120B safeguard model. We have used AMD Instinct MI 300X. For translation, we have used Savam Translate. Portuguese, for Portuguese, we have used Command A Translate. Adapter, we have did a LoRa fine-tune on the top. Thanks to Ruben for the 2x H200s for did a DDP. So evals, what we found was like the base was performing well, and the run one was a quarter of the original data set. I have done like post-processing to balance out safe and unsafe samples. The run two had like a full data set, but I think, yeah, it performed bad. Why? If you see this, yeah. So while we are in the training, we had like a huge gradient explosion, which where the training weights went somewhere else. So yeah, this is the reason why the run 2 was performing very bad. Yeah, thank you. Is this the end? I guess it's not. I think we need to do a lot of cultural aware localized safety evaluation, because we didn't had anything around cultural aware safety evaluations. Rather than we came across different dif- different evaluations like harm bench, access test, toxic gen, strong reject, but we didn't had like for all these languages to be translated. I think I want to give a huge thanks to these guys, because without these, I think we might not have done what Cohere can do now. I came across like Cohere Labs, where I found global MMLU and include base 44. I think just like them, I guess.
Okay, we're gonna have to wrap up. So sorry to cut you off, Solomon, but congrats on all the work of your team. Great excitement around both your work and your slides. So congratulations here. Your mentor, Parth, has dubbed you the underdog uprising. You were very prepared with a complete approach and questions which helped the project move. And it was also very realistic for the time frame. So huge congrats on your work across the board. Next up, we're going to move on to Divyansh. Over to you.
So our work mainly was about how the TinyAI's language identification capabilities are, and we wanted to compare how the model itself would be able to guess these languages, or the unigram-based approach on a tokenizer level, because TinyAI's tokenizer is one of the biggest multilingual tokenizers, so like are much more balanced, and so it should perform better. And the key takeaways for our project are mainly that, yeah, like on the prompting basis, the TinyAI model might not be very good to detect these languages, but maybe due to some prompt templates being wrong, or something. Sometimes they're not able to explicitly say how the languages are. But on the, like, when we did the same experiment with the command A, we were able to get these performances. But doing the same experiment with the help of the tokenizer, of using just the tokenizer, we could get the similar performance as compared to the command A. And then the second main key takeaway would be, I'm not able to change the slide. Oh, sorry.
Are you where you
Yeah,
need to be? What slide? Nice.
Yeah, so we also see that how the covered languages versus not covered languages behave. Like the not covered doesn't mean like they are not directly covered, but like either they have one-to-many mapping for these languages, or like one-to-zero mapping. And covered is like we can directly map to these languages, and we saw across the board, like even the unit approach or the prompting approach, we saw very big differences across the prompts. And then yeah, and we also see how the improvements can be done across these things. We compared with the Mistral unit approach, and we saw that the TinyAI performed much relatively better on that. And similar to that, the ensemble approach, or like taking a 20% data from the from the common led benchmark, could also improve that, and the ensemble pretty much performs the best. These are the main takeaways from the overall project. And yeah, huge thanks to the core team and our mentor, Julia.
Congrats, Divyansh. Thanks for the presentation. Nice. Your mentor, Julia, has dubbed you the multilingual maestros. Your team tested many languages beyond the supported ones. So that's really great to see, and nice to see your future work planned as well. Nice. Oh, we're moving through your appendix too. Cool. We're over to team 32. Priya, take us away.
Yes, Melin. Can I get the side controls?
Yes, I think you should have it. Oh, here you go. There we go. Nice. Let's do it.
Okay. So yeah, let me get straight to the point. So as we push for smaller multilingual first models like TinyAI, the core question is, when these models think in different languages, is the reasoning actually driving the answer, or is it just post hoc justification? For understanding this problem, we are testing 3 core hypotheses across 5 languages, ranging high to low-level resources. The hypothesis 1 is about cross-lingual faithfulness, where we are trying to see if COT reasoning on the final answer decreases as language resource availability decreases. The second hypothesis is step-level causal influence, where we are trying to see if the faithfulness is actually less in low-level resource languages than in high resource languages. The third hypothesis is linguistic alignment, where we are trying to check if the reasoning is drifting back to English in low-level resource languages as the task difficulty increases. So coming to our experimental setup, to get a clear picture, we have structured testing across 3 models. Our primary focus is TinyAI Global and 2 baselines, Gemma and Wen. We are looking at 5 different languages as shown in table, and we are also using 3 primary metrics: reasoning effect to see if COT helps at all, answer flip ratio to measure how much the model actually relies on its reasoning steps, and language compliance rate to track linguistic drift. Starting with hypothesis 1, which says that does language resource level affect how much COT actually helps? The short answer is yes. In English, we can see a massive 68% accuracy lift when using COT for MGSM dataset. But as we move down the resource ladder for Swahili, the lift drops to 41%, which indeed supports our hypothesis.
Yeah, I'm so sorry. I'm going to have to keep us moving at this point, but let's go through your slides slowly. Huge shout out to your team. Evie, your mentor, has dubbed you the faithful ones. Really engaged team working towards an ICML workshop. Nice. Okay, we're cheering for you. Really great to hear how well you collaborated and how promising that these results are looking at this early stage. Congrats.
Thank you. Thank you, Madeline. Thank you so much for Cohet team and also for Evie for constantly supporting us throughout the project. Thanks a lot.
I'm so glad. Yeah. Okay, nice. We're going to move on. We've got Edge Document Intelligence for Global Newcomers. Who's presenting here? Parth?
Yeah, go first, yeah.
Go for it.
I think the slides have not been refreshed. Could you please refresh it once?
Okay, can you start talking as we do that to make the most of our time? But yeah, I'll try to get them refreshed.
Yeah, sure. Hi, everyone. Did you know that migrants often have to sign legal documents in languages they don't fully understand? Using cloud AIs for this risks their private data. So we have made DocuNative 100% offline on-device solution powered by TinyAI. Our stack is TinyAI, BGE, and MDBERTA. Here's a quick demo. We could switch in between different languages like Chinese, Hindi, Polish, and English. And you could upload a document and ask questions from that document. So here we have a Chinese document. And you can get a confidence score of what the model thinks about the quotations from the document. And you can also get the answer for your question. So here we asked what is the rank, and it gave us a quotation from the document and also the answer in English. Moving forward. So here are our research findings. We found out, So here are our research findings. We ran 9,000 evaluations across 3 languages. On the left, Chinese scored highest at 0.527, Hindi at 0.273, and Polish at 0.209, consistent with their internal training proportions. However, the gap between Hindi and Polish is smaller than between Chinese and Hindi, despite a similar proportion difference. Whether this is meaningful or within noise requires further research. On the right, in Polish, our language with the lowest internal training proportion, the model found the right paragraph 94% of the time, but refused to answer 18% of the time. Because it wasn't fully confident, it became cautious instead of hallucinating. For vulnerable migrants, an AI that says, "I do not know," is infinitely safer than an AI that hallucinates and lies. DocuNative proves that tiny offline AI is not just powerful, it is safe by design. In phase 3, we will add local query translation and target mobile deployment to bringing DocuNative to devices migrants actually care about.
Nice. Congrats. Thank you, Parth, and congrats to your whole team. Your mentor, Ali, has dubbed you the Compass of Unseen Court. Ooh, okay. This team collaborates and progresses exceptionally. This title is chosen to reflect the idea. Nice. Okay, let's move on. Congrats to this team. Very cool demo too. Maddie, you're up next with Language Decoded. Take it away, and then I'll get you slide controls.
Awesome. Hi, everyone. Language Decoded builds on To Code or Not to Code, a paper which found English code introduced in pre-training improves model reasoning by up to 8%, even on non-code tasks. This presents a unique opportunity with TinyAya. What happens when code is multilingual? We fine-tuned the model on 5,000 quality English Python files from the stack for condition 1. In condition 2, we used Legishare to transpile them, swapping Python reserved words into Chinese, Spanish, and Urdu. In condition 3, we tested a mixture of fully Chinese code and Legishare transpiled code to test whether native code carries a different signal. Today, I'm sharing our two main takeaways. First, that the models are learning from the multilingual keywords. Code with Chinese keywords improved the Chinese XNLI benchmark by 6 points over the English code on the same exact files. This was super exciting to find. And when we dug deeper into the raw outputs, we noticed that every model actually completely ignores one of the 3 label options and never predicts neutral. And so we rebalanced for that and actually saw the same results. So the accuracy gain is really a label bias shift. That said, when we mix in code fully written in Chinese, the model hits its best common sense score across all conditions and all languages. So native code might be teaching something that keyword swap alone doesn't. Second is that the impact is language specific. Code with Spanish keywords hurts Spanish language understanding. Code with Urdu keywords doesn't move the accuracy needle at all. But here's the most striking thing. Looking again at the outputs, 43% of Urdu outputs contain Legishare Python code. It learned the translation so deeply that it can't keep code and language tasks separate. 5,000 multilingual code models or code files was enough to fundamentally change how the model processes Urdu, a language that doesn't have its own native programming language. Our crew has been fantastic. There we go. Our mentor, Tom, and additional contributors, thank you so much. We're exploring additional benchmarks and account for label bias, running additional evals and digging deeper into the details because that output is really fascinating. We'd love to expand to more languages. We just need more data. So if you speak an underrepresented language and want to try coding Python in it, let's connect.
Nice. Thanks, Maddie. Okay, you heard it, folks. The Language Decoded team is inviting you to join. To keep us moving, I'm going to post some feedback from your mentor, Tom, in the chat. It's really nice. I hope you check it out. But next up, we have, let's get this going, the Topology of Culture team. Go for it, Tanay.
Right. Thank you. All right. So TinyAya is built for multilingual communities and it speaks 70 plus languages. But we really want to understand, does speaking a language actually mean understanding its culture and how deeply? If you look at Edward Hall's iceberg model, culture has multiple layers. On the surface, we have visible artifacts and traditions. In the middle, you have behavioral norms and social rules. And on the deep level, you have values, the moral foundations that shape how communities reason about family, obligation, God, what's right and what's wrong. We want to understand the full terrain, the topology of culture that these models actually carry, and so we mapped it across 5 Indian language communities. We asked 3 pressing questions. Does TinyAya homogenize? Does its understanding go deep? And does regional training actually help deepen cultural understanding? To answer these questions, we tested 3 TinyAya models across 5 language communities using 3 benchmarks and over 18,000 data points. Our first finding was that the models lacked regional cultural knowledge. On testing with the DOSA benchmark, we found that 80% of questions were unreachable. The model only recognized globally famous items. When it guessed wrong, it substituted. A Marathi folk dance became Gujarati, Bengali music became Punjabi. Second, the models also homogenized Indian cultures into one. We tested 42 World Value Survey questions, comparing model responses against 1,500 real Indian respondents. We prompted in
source language and independently in persona prompting too, and both showed the same thing. 12 out of 12 times, the model's values are closer to Hindi speakers than to the actual language community. But our most insightful finding was that the problem isn't language ability. On Milieu, that tests reasoning in native Indic languages, Fire does win. Fire even outperforms IR23, which is a model 4 times its size. This shows that language processing is fine, but cultural understanding is not. Lastly, we plotted model responses on the Engelhardt-Welzel cultural map alongside 66 countries positioned by their values. As you can see, the model responses are much farther than India, superimposing on the US and Protestant Europe. In all, TinyAI speaks South Asian languages. Our work maps what it would take to understand them. Thank you.
Nice, Tanay, right in time. I'm putting feedback from your mentor, Julia, in the chat. Huge congrats to the whole team. Just 2 teams left. We're so close. Next up, let's go for it. Lakshmi, take it away.
Hey, so our initial piece was to do fine-tuning around any of the shared linguistics across Indic languages, and specifically around Telugu because it was low code language, and also because it shares grammar with Sanskrit, and words are borrowed from Tamil and Kannada. That's the evolution of the language. So when we did start off, we started off with Romanized text and custom prompts, and we realized that the TinyAI Fire was always defaulting to North Indian languages. But the reasoning accuracy was still high because of the shared Sanskrit context over there. Outside of that, what we have also found out was that as we tested some of the custom native prompts, we found out that it allows for some level of sophisticated reasoning. However, when we did do some of the, I'm unable to, okay, let's see. So when we were doing the adversarial analysis, we found out that the language, when we're giving the prompts in Telugu, it was able to identify them, at least for custom prompts, when the prompts are harmful across the board. But when it comes to cultural nuances such as cost, we found that the model often failed. However, I believe that if we are able to train the model more on the cultural context like cost and stuff, the model would be able to perform better. Another observation that we did find out is that most of us millennials and Gen Z, we do not use our language to write our language. We use Romanized text. So we do understand that it wasn't tested for the Romanization, but whenever Romanization is coming into picture, because of the shared linguistic nuances, we do need to do a better piece in identifying the grammar over there. And for next steps on the future, we are planning on hand translating 315 of the DAMO Harmbench results in formal Telugu conversational and regional context, and see how it will perform better against Gwen and everything else. Yep.
Thanks, Lakshmi. I'm going to move us. We're squeezing in at the last moment. Some feedback from your mentors in the chat, but take it away, Mansoor. Is Mansoor on the call?
Sorry, mic was muted. Sorry, can you hear me?
Yeah, go for it.
So let's start up by the motivation for our project. So we have noticed that in communication, daily communication, we use code switching from English to Arabic, and that some papers have suggested that code switching can result in a jailbreak with a high success rate. And also prior research has not explored that difference between different types of code switching, particularly changing some parts of speech and the effects. So let's see the setup of our experiment. So we picked 3 data sets: blend for the cultural understanding, and nomad for the cultural norm, and multi-GAL for jailbreaking. The 3 dataset has English and Arabic, so that allowed us to get a baseline of how the model will perform, and then the effect of mixed language. And we set up 3 questions for our analysis. First one is the facts more robust than duplicate, and can bilingual trigger hallucinations inadvertently, and which code switching style works the best? Okay. So let's see the answer for the 3 questions. For the first one, yes, facts are more robust than etiquette, at least for TinyAI. And for the second one, we noticed that mixed language has produced jailbreaking with a very high success rate, so we might develop safeguards, particularly for code switching. And finally, we have not noticed any effect between the 2 code styles we have picked. So for the first one, we picked changing the nouns and the verbs, and for the second one, we changed the verbs and the question words for a different language.
Mansoor, thank you. I'm going to move us on. Great to see you've got plans for future work. I'm putting some feedback from your mentor, Tom, here. Okay, I know we're over time. If folks have to drop, thank you so much. We're going to squeeze in one more sneaky presentation from Team 2 who snuck in. Vidit, go for it, and I'll give you slide control.
Thanks. If we were trying to understand how the information is encoded between different layers of TinyAI Global and TinyAI Regional. So we were able to complete 2 different analyses. Adit, over to you, man.
Hi. With the TinyAI under the hood, we were trying to understand how TinyAI understands with each layer. Does it go and recognize words, grammar, meaning as we go deeper into the layers? For the dataset, we have used 3 controlled English pairs split equally across 3 linguistic types, and we keep it design choice as this because we want to isolate the variation and keep one thing changing at a time. We tested 2 ways to get sentence embeddings. Mean pooling gave everything a similarity of 0.99, which was completely flat across all layers, and there was no signal at all. The last token pooling actually showed differentiation, so that's what we used. Some of the main findings were lexical similarity is highest at the every single layer, and the model never moves past the surface form. Semantic and syntactic similarity grows from 0 to the 33rd layer, but they never catch up to the lexical. The gap between the lexical and semantic actually narrows in the deeper layers, so that's where we see a weaker pull towards meaning, but it never wins. Sometimes something interesting happens at the very last layer is all 3 signals drop sharply. This is the output layer preparing for the next token prediction. It's doing a different job than the middle layers. For conclusion, we can say that the last token pooling is the right pooling method for this kind of analysis, and the dataset design matters a lot. Synonym swaps are so similar, they set a high ceiling for semantic pairs which they can't reach. So cross-lingual pairs and testing with them would be a better thing. And for work in progress, we are working to test cross-lingual alignment for this for TinyAI and its other distillations. And from here, Daniel will continue.
Yeah, I'll be very brief in what I say. I ran an analysis. It was a direction injection analysis. Some of my main findings. So we looked at 12 languages. The vast majority of them, we saw sensitivity peaked in the first 5 layers and then dropped off from there. So essentially, this is hinting at that the model knows what language it's dealing with almost immediately. The one exception we did find was Amharic, and that peaked much later around layer 9 to 16. There's a number of different hypotheses we could have for that. And then most importantly, all 4 model variants produce nearly identical profiles. And so this also can hint that maybe the regional fine-tuning doesn't change where language identity lives within the model. So thank you.
Amazing. Thank you so much. Glad we got to sneak in the Under the Hood team. I'm sharing some really nice feedback from your mentor. Weigh in the chat. I hope you get to see it. Wow. Okay. No one needs coffee anymore. We are all jazzed up on this. Is honestly, I'm blown away. This was an experiment for us, running the expedition in this way, significantly reducing the build phase to 2 weeks. And you all delivered. Huge congrats on all the progress made. Marzia, did you have any final words before we close out?
I mean, this was very inspiring to see what everyone can do in just 2 weeks. Shout out to all of the mentors, all of the captains, every member of the team. And we just wanted to highlight again, this is not the end of a research project. It's very important to also share your work, your finding, whether it's about continuation of your experiments and analysis, or this was a good presentation practice, but sharing it even more publicly in forms of blog posts, papers, putting your data sets out there. And we are here to support you in phase 3 to do that. So let's continue these conversations, and good luck with every project. And thanks for a great presentation. And yeah, huge shout out to Madeline and Brittany as well. It was a great session today.
Thanks, everyone. We'll be in touch. Don't leave Discord yet. Let's stay in contact and figure out how to move into what's next together. Okay, thanks, everyone.